Humanity is renowned for having an insatiable need to examine everything around us. We have traveled around the world innumerable times, explored the closest space, and constructed outposts on Antarctica. However, there are still locations on the world that have never been visited by humans, and they are just beneath our feet. The actual nature of what can be found at a depth of tens of thousands of kilometers is unknown to science. The rocks we can remove from there, though, are just as precious as the samples that a spaceship returns from a distant planet. But what precisely stops people from probing so far below the surface? And what achievements have been made using the world's deepest Kohl's well, first in space? Since the XII century, people have been involved in the process of drilling very deep wells. The fundamental justification for doing research of this nature is the potential existence of a vast array of undiscovered things underground. For instance, a few years ago, geochemists from Germany, France, and Russia found an underground ocean from the Archean period that is 500 kilometers below the surface and has a volume greater than all surface seas combined. Science was able to learn more precisely about the characteristics of our planet's origin thanks to this finding. And without the use of ultra-deep drilling technology, such findings would not have been conceivable. The Kola ultra-deep well, which is still the deepest in the world even 24 years after it was shut down, is one of the most spectacular examples of such a project. The Kola well was built starting in 1970 and lasting until 1991. The top hole measures 92 centimeters in diameter and extends to a depth of 12,262 meters. With the aid of the Uralmash 4E drilling rig, this item was drilled. At a depth of 7,263 meters, Uralmash 15,000 took its position. It required almost 200 tons of weight and over 18 hours to lower and raise the column. 10 kilometers to the west of the village of Zapolyarnaya, the drilling location was selected. The well is situated in the Baltic Shield's northern region, next to a juxtaposition of ore-bearing and Cambrian formations that are indicative of the prehistoric Earth's crust foundations. The Kola Peninsula is one of the few locations on the continental surface of the planet where the sedimentary cover is entirely absent, making this area the most practical for ultra-deep drilling. And the surface is made up of rocks that are roughly 3 billion years old and have a very ancient origin. The Kola well was constructed only for scientific study, in contrast to other substantial ultra-deep wells that were built for oil and gas production or exploration. Its primary goals were to validate theoretical interpretations of the composition of the lowest layers of the Earth's crust and examine the characteristics of the borders between these layers and the mantle. The researchers simultaneously intended to gather data on the deep structure of the nickeliferous Peckenegin complex, explain the unique ways in which geological processes manifest themselves, and gather fresh information on the thermal regime of the subsurface, deep water solutions, gases, and rock composition. The Kola well was also expected to contribute to the development of complicated geophysical study techniques for rocks and ores at very deep depths, as well as the enhancement of the already used ultra-deep drilling technology. On May 24, 1970, the well drilling process started. The operation worked rather well up to a depth of 7,000 meters since the drill only encountered uniformly dense, sturdy granite. But after traveling more than 7 kilometers, the drill hit weaker stratified strata, and as it moved through them, the wellbore started to collapse and voids started to appear. As a result, the drill frequently broke off while attempting to raise, and the string stuck. Several of these mishaps led to the well's construction finally resembling a tree crown with several branches. The Burt Rogers oil well in Oklahoma had previously held the record of 9,583 meters, which was broken by the Kola Super Deep on June 6, 1979. Additionally, the hole was 1,266 meters deep in 1983. After achieving this record, drilling was momentarily put on hold. A few months later, when the procedure was restarted, the first significant mishap happened. Additionally, drilling had to restart at the 7-kilometer point. The new section descended 12,262 meters by 1990. However, following a number of other serious mishaps, the procedure was once more halted, and after 4 years, the well was eventually sealed. At first, it was anticipated that the Kola borehole would contribute to the identification of a distinct border between granites and basalts. But over the whole depth, only granites were found in the rock samples. Granites altered physically at the same moment due to high pressure and high temperature. And frequently, granite broke apart when the samples were hoisted because it could not sustain the sudden pressure shift. A powerful rock could only be removed by elevating a drilling shell very slowly. and as a result, the scientists were able to learn a great deal of useful information about the interior of the Earth. The geothermal survey's most significant finding was information on the borehole's temperature, since the temperatures there were far greater than anticipated. The rate of temperature increase was 11 degrees per kilometer close to the surface and double that at a depth of 14 degrees per kilometer. The temperature increased between 2.2 and 7.5 kilometers at a rate of around 24 degrees per 1,000 meters. As a result, sensors detected a temperature of 70 degrees Celsius at a depth of 5 kilometers and 220 degrees Celsius at a depth of 12 kilometers. At the same time, knowledge of the Baltic Shield's deep structure further clarified pre-existing theoretical concepts. Data that were collected differed greatly from the knowledge that scientists had before to the well drilling due to the examination of the composition of ultra-deep rocks. The scientific findings also included practical ones. Geologists discovered a layer of miniable copper-nickel ores, for instance, at shallow depths. Additionally, a layer of geochemical gold anomaly with a gold content of up to 1 gram per ton of rock was discovered at a depth of 9.5 kilometers. Even while it is doubtful that mining would ever be able to reach such depths, the gold-bearing layer's very existence and unique features helped scientists to better understand how these minerals evolved. Only a well recently sunk for the goal of creating substantial gas and oil resources was able to beat the record for the length of the Kohl's Ultra Deep. One of these wells was the 12,290-meter-long oil well Maersk OBD-04A, which was dug in 2008. And at 12,700 meters long, Z42 of the Chavo field is currently the longest well. The Kohlskoye well's depth, however, was unbeatable. Aside from its record-breaking qualities, the Kola Super Deep Well has a unique history that has accrued many stories and enigmatic mysteries throughout the years. This was mostly brought about by a number of incidents, the causes of which scientists occasionally struggle to explain. For instance, a mysterious explosion occurred in 1995 near the well's maximum depth, forcing drilling to cease. It was never discovered what caused the event. Academician David Mironovich Guberman, the project's chief, stated that a weird noise had preceded the explosion. A few days later, nothing comparable occurred at the same depth, though. The possibility of the drilling rig itself breaking down as the root of the problem is very real, or an interaction with a material there that hasn't yet been studied. After all, we have barely scratched the surface of the globe's deepest depths. Only a small portion of the distance to the Earth's center has been covered by the Kola Ultra Deep. It is a total of 6,371 kilometers away. The goal of the well's construction team was to at least reach the Earth's mantle. They would have needed to go an additional 30 or 40 kilometers to do this, though. Even yet, the outcome is still incomprehensible. Additionally, no machine has ever descended thus deeply below ground. Geology is now evolving with space exploration initiatives, and such study is comparable to the telescopes we are all familiar with. Geologists also have their own big objectives at the same time. Additionally, a portion of the scientific community is considering ways to reach other worlds. The other involves planning how man will eventually be able to go to the center of the Earth by examining the structure of our own solar system.